Hello everyone, welcome to the Sneaky Code live stream, where we're going to talk about some Clojurescript and how to get started. Yeah, so welcome. You guys are welcome to ask questions in the chat or whatever. This is my first live stream. Interesting, here from the middle of the Free State in South Africa, in the middle of nowhere. That's why the stream quality isn't as high as it can be, because we're in the rural areas, but we can go ahead nonetheless. Right, so before I start, just for those that's new to Clojure and Clojurescript, I figured let me just give a little overview of what Clojure is. So just stop the music. Okay, all right. So first of all, Clojure is a functional, dynamic, hosted list. All right, so that's how Rich Hickey, the creator, typically explains it. So I'm not going to do a deep dive into all these things, but just so you know, just so you have an overview. So I'm going to start with Lisp. So the easiest way to explain what Lisp is that typically your code looks like this. You might have a function, and then when we use Lisp, we just move that first bracket to the start. Basically, the idea behind Lisp is that that there is no distinction between your code, how you describe your code, and how you describe your data. And that leads to quite a few awesome things that you can do. And because your code is data, your data is code, your code is code, your data is data, but they're also the same thing. That's called homoiconicity, if you want to go and look it up. Clojure is a dialect of Lisp, and it's also one of the easier Lisps to learn. Now, when I first saw Lisp, I mean, everything looked like a bunch of brackets, like that, and there's many jokes about that as well. But once you start dealing with it, it's actually pretty awesome. I'll go through some syntax in a bit, but yeah, so I've been doing Clojure for about 2 years, and Lisp is pretty awesome. Definitely, I'd suggest that you go and look at it. The next thing is hosted. So Clojure and Clojurescript, but Clojure was originally designed to be hosted on the JVM, and the idea behind that is that you get the magic that is Clojure, but you also get the ecosystem that is Java and the JVM. So many problems that have been solved by people, you get access to their code, to their libraries, and Clojure is also very specific about how easy it makes interrupt. I'll show you in a bit. And the same for Clojurescript. So Clojurescript, when you look at Clojure and Clojurescript, they don't really look any different, and there's some differences under the hood, obviously. Clojurescript, which we're talking about today, targets both the browser and Node. It's built on Google Clojure. Yeah, pizzas. This is the IDE for ants. I'll boost it a bit. How's that? even like that. All right. Just shout if I should make it a bit bigger. Anyway, so hosted, Clojurescript targets Node and the browser, and again, you have easy access to all the underlying libraries. So you can use React, you can use whatever you want. Yes, Clojurescript is built on Google Clojure, Clojure with an S, like this, Clojure. Not to be mistaken for Clojure with a J, that we're talking about. It's basically a JavaScript library that Google builds, and if you're using anything Google, it's built with Google Clojure. It provides quite a lot of interesting tooling, and Clojurescript uses it for its bundling, etc., for tree shaking, dead code elimination. You get all of those things. That's it for hosted. Then I'm going to quickly jump into functional before I go to dynamic. Functional, so Clojure isn't like Haskell, which is this very strict functional language. You're not allowed to do any side effects. What Clojure means, what Clojure uses functional for is it's how you build apps with Clojure is in a functional style. So I mean, you can take JavaScript and you can build apps in a functional style or in an OO style. So Clojure promotes a functional style. It has a bunch of immutable data types that are very performant under the hood as well. The same for Clojurescript, and Clojure promotes pure functions, simplicity. But what's nice about it is it doesn't force you to do that. So if you want to you can do whatever you want. Clojure it doesn't try and force you into a corner with how you can do things. You can really do what you want, but it's built around the functional concepts. And then finally, Clojure is dynamic, so it's dynamic in the JavaScript sense, but what they also mean by dynamic is how you typically run Clojure is that you don't have this write code, compile the code, run the code, test the code, stop the code, write the code, compile the code, run the code, test it. You don't have that kind of cycle. It's more you start up a Clojure system and then you dynamically add to it. You start from very small bits, small functions that you then compose together and add on, and you can because it's dynamic, you can replace these things as the Clojure REPL is running. It also leads to this thing called interactive development, which I'll show you a bit about later. All right, enough babbling about Clojure. Let's start with Clojurescript. So at this point, I'm going to assume you have installed the Clojure command line tools. If you're running on Mac, it's very easy. Brew install Clojure. Linux, you can go look at the Clojure website. Windows can't use the Clojure command line tools yet, but there are some build tools like Lineagen or Boot that you can use on Windows. As for tooling, text editor support, I'm using Spacemacs, which is just Emacs with fancy stuff on top of it. And then IntelliJ as a plugin. Cursive is the name. If you're using Atom, there's Proto-REPL, which you can use. There's a similar thing for VS Code. So you can you don't have to run Emacs or learn Emacs to do Clojure. There's many of the existing text editors can support it. I just use Spacemacs because it comes with a cool Clojure layer. I'll be using Clojure and Clojurescript interchangeably. because it's very similar. It just ultimately at the end of the day, you're either running on the JVM or you're running in JavaScript. Right. So to start off, what do we want to do today? So I'm going to set up a small Clojurescript app that has all the bells and whistles: live reloading, CSS reloading. Yeah, and those are basically the things. React, I'll add React quickly using a wrapper library, and then basically the plan is to show you how easy it is, and I'll do a little overview of the Clojure language at some point when I feel it's needed. It's very simple. The syntax is like one rule, and then you technically know Clojure. So yeah, so let's get started. I'm gonna make I don't really have a name for the app that I want to make. I think I'm just going to call it Sue. This will probably be the start. I want to build like a financial wealth tracking thing at some point. So this will probably be the start of it. Nate bought 5,000. It is fun. Definitely. So I've been doing Clojure for about 2 years now, and honestly, like it's fun. The one thing that I noted is that once I moved to Clojure, I started completing like side projects, because one, it makes you faster, and it's enjoyable, and it's easy. It's simple. Yeah, go search for all the Rechecky talks about Clojure, and you'll see what he's on about. All right. Anyway, let's get started. I'm just going to call this Sue. Yeah. So Spacemax is Vim with is Emacs with Vim on top. So I use Evil Mode. I'm not the best text editor or text. Yeah, I'm not the best typist. But yeah, Spacemax is quite cool because you get the power and the flexibility and the extensibility of Emacs with the editing of Vim. All right, so let's make Sue, and the first thing that we need to do is make a file called deps.eden. So Eden is short for extensible data notation. It's like XML or like JSON or whatever. It's a way to describe data, and that's what Clojure uses. Coincidentally, how you describe it is the exact same way that you would write your Clojure code. It uses the same kind of types, etc. So I'm going to make that deps.eden file. It's similar. So if you're coming from Node, it's similar to your project project.json file. Projects, and what do I call it? Sue deps.eden. All right. And what I'm going to put in this file is I'm going to put deps, which is my dependencies, and I'm going to add 2 dependencies. What's nice about this deps.eden file is that you can add dependencies from Maven or directly from GitHub. So if you've got the GitHub repository and the hash, you can just import it. I think it's similar with Go, or even local libraries. You can simply add them. So I'm just going to copy these 2 libraries. Now the first one that I'm going to use is thank you Docker, is called Figwheel main, and Figwheel main is what's going to give us our live reloading environment. It's technically a REPL, a read, evaluate, print loop, but that runs in the browser, and then it's got some bells and whistles around it. And the second thing I'm adding is this rebel readline CLJS, which is just it's a nice wrapper for your terminal. And I'm going to save that, and then just jump over to iTerm, and then I'm going to I typically do everything inside of Spacemax, but I want to start this way just because and then what I'm simply going to do here is run Clojure, and I'm going to give, say, the main a file that it needs to use is Figwheel .main. Now what's happening is this is starting up. I'm just going to leave it there for a bit. It's fetching these two dependencies, so that might take a second or two. And then it is starting the REPL. Now the first thing that you noticed is it actually opened the browser here. So what Figwheel does is it starts the read evaluate print loop. So if you don't know what a REPL is, basically, let me show you rather, is you can type some code and then you can send it for evaluation, right? And then you can do this over and over. And what's nice about the Clojure REPL is you can actually, inside of the REPL, build your entire application. So you can define functions, you can define variables, and build on top of that. What Figwheel does is it actually takes this code and it sends it to the browser, executes it inside of the browser as JavaScript, and then sends it back. So that's not what I want to do. No. I want the dev tools. All right, so technically if I do, let's hope this works, test, or let's do hello world. As you can see, so it actually executed it there inside of the browser. Another fun one is I can do, so if I do /j or /, then I'm in the browser context. So I can do alert hi, and it will actually pop that up inside of the browser. Yeah, so that's, I'm not going to talk too much about Figwheel. It's got a bunch of settings, but I want to keep stuff as simple as possible and just get us going. Yeah, all right, so I'm gonna just exit here, REPL quit, and then I'm gonna move on. And you can see there the connection died. So, right, so the next thing that we need to do is, obviously, this is not the application that we want, right? So Figwheel loads this as like an informative bit of documentation, but obviously this is not what we'd want. So we'd like to add some things. We'd like to add some actual Clojurescript, some CSS that reloads, HTML, etc. So the next thing that we're going to do, before I do that, I just want to init this repository, because then then I can actually start using no man yes, I can use Magit, so sorry, I'm rambling. I need the repository because Spacemax has a package called Projectile, and Projectile picks up your Git, what do you call it? Your source code, man, and your Git repositories, and then it treats it like a project. So you can find files within the project, create files within the project, etc. So the next thing I want to do is I just want to create a Clojurescript settings file. It's not really a settings file, it's more like a profile. So I can create one for dev, I can create one for production, and then I can put some stuff in there. I haven't worked with Webpack for a while, but Webpack, I think I was on Webpack 2 or Webpack 1, I can't remember, but you could set up different configs for different builds, etc. So the first one I'm going to do is just dev, and then you always do .cljs. And again, it's an Eden file because it's just data. And all that I'm going to do in here is I'm going to say my main file is su.core. Okay, that's all I have to do here. Then I'm going to add another file, and I'm going to add this at source/su again. So this is kind of the Clojure standard. You've got your source and then you've got your namespaces. So this namespace is su, and then the file would be core.cljs. Yes, please create that directory. And now I've got my file over there, su.core. Just want to make sure I've got everything I want in there. Yes, I do. So now what's remaining is an index, because I can technically run this. Let's do that. I can technically run this using this command. I'm going to copy and paste it so I won't bore you with the typing. So basically it says run Figwheel main with the dev build, so dev dot, so it will look at that dev.cljs file. We wait for that to start up, and now that should load this file as my core. We'll just wait for Figwheel to start up. It's going to pop up a new window. Again, I haven't added the index.html yet, but now what I can do is I can say I'm going to say a print, and just again hello world, and let me just open the dev tools again over here. And now if I change that and I save, you'll see that it actually reloads this code and it prints it down there. Okay, sweet. So we've got our JavaScript hooked up. That was fairly easy. The next thing that we can do is we can add an HTML file. We'll put that at resources.public index.html. Yeah, I'm going to put it there, create that, and I'm just going to copy some of this HTML over here because I don't enjoy typing it. But it's fairly straightforward. Not much. What I'm doing is over here is I'm loading that dev main. So let me just show you. So once Figwheel is running, it's actually building that JavaScript into this target. So target public CLJs out dev main. So there's our JavaScript file after it's been processed by the Clojure compiler. In dev mode, it doesn't do any like uglification and minifying and all those fancy stuff. I'll show you a bit later how we get that running. But now we've got this, and then what we just need to do is in our deps.eden file, where are you? There it is. We just have to add our paths. So I'm not actually very familiar with Java, but this is some stuff to do with the class path. So that's still something I need to teach myself about. I just know it's there and things need to be on it. I'm going to put target on there, resources on there as well. And then I'm going to just kill this REPL again. and run it again. And now it should open a new window with my HTML. Let's just wait for that to happen. Oh no! I messed up. Let's see, what did I miss? Nothing there, nothing there. Nothing there. Did I misspell something? Resources. Oh, that's right. Why is it complaining? Let me just make sure I actually saved these. That's saved. All of this is saved. Let's try again. If you know, if it doesn't work, turn it on and off again. Replicate. Yeah, that's what I got. Come on, Figwheel, help me. No! Help me, chatters. What am I doing wrong? Is resources spelled correctly? Why? I feel blind. RESOURCS. Public. Oh, that's what I did. Come on. Oh, let me just do clean. Might actually be that. See, exists, but the resources directory is not on the class path. Okay, so there's my error. Just read. Okay. I probably made a mistake here. Paths. Alright, that needs to be an S. Okay. Eventually, you will get it. Alright. I missed the error due to the tiny resolution. Let me kill all these little ones. There's a cool, the guy that wrote Figwheel has a cool little video of how he edits Flappy Bird. Oh man. What is the problem? Spelling. My friend Pizzos will know that I'm great at spelling. Alright. Thumbs. Hold your thumbs. This should do it. Live coding. So much fun. Geez, we're already 40 minutes in. There we go. So there's blank, which is great because that is exactly what we want. I can go to the index file, do something interesting like this. It's really not interesting. just to prove that we have in fact reached the correct file, and there we can see hi. Right, okay, so there we go. So now again, if I go to my JavaScript file, I can just do, let's do another one, .log JS console I. Let's do an alert. No, do a log. Okay. Let's save that. And there we see hi over there. If I change it again, I mean it's straightforward stuff. The next thing we want to do is we want to add some a CSS, which again is fairly straightforward. We'll add a file that will also go in your resources. Public CSS. I'll call it style.css. Let's just do body color red. And then we want to add that to our index.html file. I'm running Bulma. I enjoy Bulma as a CSS framework. It's easy, it's pretty, the SCSS is easy to extend. Okay, so this won't actually live reload the CSS yet. But what I can do is I can go in here and I can do a caret, and then I can put this data over there. So I can say, please, the CSS directories is resources public. CSS, and that little thing just indicates its metadata, and it tells Figwheel this is your settings. But I might want another config file for production or whatever. So what I'm going to do instead is just create a Figwheel main.even, and then I'm going to pop it in there. Oops, I'll pop it in there. And then again, for the final time tonight, I'm going to restart this REPL, and then I'll move to Emacs. Just double check that file name is correct. Let's say yes, Figwheel main. Kill that one, kill that one. There's no text here, so let's just put some text in here again. Just gonna put that, refresh. There you can see it's red now. If I go to the style sheet and I make this blue. Alright, so now we've got code reloading, we've got CSS reloading, and again, I mean, we added like 4 files. Right, so what I'm going to do next is I'm going to step away from the command line, and I'm going to use CIDER, which is an Emacs package that's inside of Spacemacs currently, and I'm just going to call the Clojurescript jack-in function, and then that's going to start Figwheel, but it's going to start the REPL inside of Spacemacs. It's going to connect to it via Spacemacs. It starts a REPL server, and then again it does magic that I haven't bothered to learn. So I choose Figwheel main, I choose the dev environment. Again, this is going to open a browser. So now this is another one we'll be working in for the time being. Now, what's nice about this is that where I used to had to type stuff inside of the console, I can now type stuff directly in this file. So if I want to do +1 and 1, and I can evaluate it right there, and it will spit out 2. And again, what's happening, it's taking that function, sending it to the browser, evaluating it, grabbing the what do you call it, the value, and bringing it back. Again, I can do JS alert 1, 2, 3. If I evaluate this here, it will actually alert in the browser. But what's nice, it's in my file, so I don't have to copy my code from oh, there's an exception. I don't have to copy my code from, oh, it's because it's not returning a value. I don't have to copy my code from the actual command line into my files, and vice versa. Alright, going to delete. Oh, it actually ran it twice because it saved the file. Okay, so this is it. What I want to do next is, before I continue and actually write some Clojurescript, I just want to give you a very, very short overview of Clojure and Clojurescript. So everyone's still all right? Are you still hanging in there? I see we're hanging around 8 viewers, so it's nice. Not everyone is left. I feel so validated. All right, so let's look at Clojure and at Lisp. So I said that you get, let's do JavaScript, so you can do function f, right, and then there, and then you do that. Right, so what you do with Clojure is that you take this opening bracket and you move it all the way back. What am I doing? Right, you move it all the way back and you move everything inside of those 2 brackets. And then what this becomes, and this is Lisp syntax, and it's almost the only syntax that you have inside of Lisp. It's what do I want to do? Okay, so your function, followed by argument 1, argument 2, argument 3, etc., etc., etc. And this is Lisp. This is all the syntax that you would ever have to know. All right. So I mean, who here has ever like, who here remembers what a switch statement looks like? Okay, I never do, so I always have to Google it, right? And those syntactical things that differ between language and language that you have to learn is all overhead. With Clojure, you don't have that. With Clojure, open bracket or open parentheses, what do you want to do, close parentheses. So all that you have to learn is you have to learn the API. You have to learn what do I do. So let's take a simple one. You've seen this now a bunch of times. I've got 1 and 1, right? So this is adding 1 and 1. But I can add a bunch of 1s and it will spit out 10. Okay, so straightforward. Let's do something a bit more familiar. Let's do an if statement. So if, well, before I do that, let's define a variable. All right. So similar to similar to const in JavaScript, const a equals 1. We can do def a1. Right. So now, and you'll see that evaluated to a symbol. Right? So it returned a symbol. So if I evaluate a, it returns 1. Okay. So now we can do an if statement. So if, and what I want to do is I want to check if something equals a. So if I can say if a equals 1. So again, let's take a step back and just look at this. So equals is just a function. Does a equal 1? It will return true. Does a equal 2? It will return false. And then over here I can say return true or plus 3 with 2. Alright, so this is the truthy value, that's the falsy value. So in this case it will return the number because it's adding that, and if I make that 1, it will return the string. So again, that's just this expression, okay? So I'm adding 2 stuff. In this case it's just a string, so I don't have to wrap it in anything. Again, if I have 1 would just evaluate to 1, for example. But this is Lisp. Now, coincidentally, people typically get frightened by the brackets, but there's less brackets here than you would do in like a JavaScript if statement. Almost. I think it might be the same actually. But yeah, all right. So in many cases, there's actually less. It just gets scary because at the end you might see something like that. Okay, all right. Okay. Any questions? Nothing. All right. So that's Clojure. Very short. Clojure has some other things. So the next thing that you have to learn is the data types. So we've got strings, we've got numbers, we've got that's integers, we've got doubles. Clojure actually has like a what do you call? Oh no, JavaScript doesn't have it. I'm being stupid. You have to divide like that. So 80 divided by 99. I don't think it's implemented. Clojure has fractions. Clojurescript doesn't. I might be wrong. Then our basic, we've got a symbol. So if I quote A over here, A, it's just A because that's the symbol. Then we have this interesting thing, foo, which again just evaluates to foo, and that's what you saw in the Eden files. I mean, that's what we call a keyword. So keyword is kind of like a symbol, but it evaluates to itself. And then we've got our main thing. So if you want a map similar to an object, foo is 1. Okay, so that's an object. It can take anything. It can take other maps as values. So it's basically a key value pairs. The nice thing is that this can also be anything. Okay, so this is valid. This can be a random. Let's do that. So you've got a GUID, a GUID that's linked to a string, etc., etc. For lists, we have these things called vectors. 1, 2, 3. That's a vector. How vectors work is when you add to them. So you can do conjoin 1, 2, 3. If I conjoin 4, it will add it to the end, right? Another one that we have is we have lists. Now lists are represented like that, but obviously we're using that as a function call. So we'll just quote it. So that's a list. And the difference between lists and vectors is that lists append to the front. So 4, 1, 2, 3, and then there are some. You'll use one or the other based on what your requirements is. It's rare that you define lists like this. You'll typically define vectors. Also, Clojure has sets, which are unique. Oh no, what's wrong? Oh yeah, all right. I can't instantiate it with a duplicate key. Add Peter. So if I do that. You can replace that hash curly bracket just with the actual set function that takes a collection. So if I do this, it will return just 1 and 2. So it returns unique items. Yeah, if I want to define a function, it's like that def above, but just with an n. Basically, it means define function. It takes a name, so name. And that's its name, some parameters, and then a function body. Okay, so if I do name 1, 1, 2, it will return 3 if I hit the correct keys. What? Oh, a plus a. Oh, I'm stupid. Okay, so 3. And see how I'm just evaluating the code, playing with it right here. I'm not hitting compile, I'm not leaving my file. All of my code is just evaluated here. Yes, a list is a, so the question is a vector is array-like and a normal list is linked list-like. Yes, so vector is, yeah, that's right. So again, it's, if you want to add to the front, it's expensive in a vector, where it's, yeah. All right, so I can also do this. Def. So that just says, please define a function. This function just returns what you give it. For example, we can call this I. All right, so that is a function. Okay, it says object here because it's sending it to the browser, and functions in the browser is objects. If we were running in a Clojure REPL, not a Clojurescript REPL, it would have done something different. So again, now I can say I can call I with a string, and it will return that string. Clojure has also has a shorthand for anonymous functions like that, where you don't need the arguments list. How would I do that? Do that. All right. So let's do this. We say inc. So this will then, this is an anonymous function, and it takes a single variable. We can also say it's an anonymous function and it takes 2 variables. In JavaScript you can pass it many variables because again it's a function. So if I do this, I1 and 2, it'll add them, but if I add 3 now, nothing will happen because it's JavaScript, right? So it just ignores those. But if this was Clojure, Clojure would actually throw an exception saying like you have an argument exception, you've provided 3 arguments where it only takes 2. So again, those are like subtle differences between Clojure and Clojurescript. Because Java is statically typed, it will catch those things for you. Armadon. How's it? I have no idea. You'll have to remind me. You send me a Twitter, an image to Twitter, and then I can wave at you, and then I know, because you see my face and you know who I am, but I don't know who you are. But it's nice having you on the chat. Thank you for joining. Right. Okay. I'm gonna stop there. It's the basics, the very, very basics. The last basic that I'll show you is again, interrupt. Okay, so I can do document dot get element, that's wrong, element by ID, and if you remember correctly, not there, in the index file we had a this app. I'll delete that. So if I do that, I should get that back as an object. And then I can do stuff with it. So this is, you can do this, but the actual Clojure automatic way is to put this in front, and that dot just means it's a function call on an object. So we've got get element by ID, the document, and the app. So it will evaluate to the same thing. I can wrap that in a inner HTML. And let's put the just foo bar. And now I'm going to show you something interesting, because over here in Figwheel is complaining that it has no idea what this symbol over here is. So that's quite nice. That Figwheel will tell you there's something wrong with your code, and it won't even it won't even compile it and send it to the browser. It will wait for you to fix it. So I am going to simply delete all those. Hit save again. It's going to run and it's not going to work. Why? Oh, it's not working because this would have to be, I think, something like that. Because it's a method and not a function, there's an interesting I think you put it there. No. Okay, I'm going to leave that and stop embarrassing myself. I can't remember exactly how you run. If it's, I'll have to go look it up. Because that's a method on, there's just another syntax that you have to use. It might be that. It's not that. Let's see what the browser tells us. What is not defined? Yes, I know it's not defined. Oopsie. It's not a function. Yes. Why is it not a function? I'm not gonna waste time on that. Shows you my lack of JavaScript knowledge as well. Right. Alright, so let's add React, because that's easy. So I'm going to use a library. So there's, before I get there, why React and Clojurescript actually works really well, because of just how React is built, and you can write components that are just kind of like functions and very pure, etc. Technical mumbo jumbo that I'm not going to try and embarrass myself with. If you use React and Redux, Redux was actually based on Clojurescript with React. At some point, I can't remember if it was faster or if it was smaller. Like if you ran React through the Clojure compiler, it actually spat out either a smaller. Yeah, I think that was that. It spit out. It's actually smaller when you run React through the Clojure compiler than, because it eliminates all the dead code. Anyway, I'm rambling. So there's a library, a Clojurescript library called Sablono that wraps the React library. And then there are a few other React wrappers that actually all of them wrap Sablono. So the one is called Reagent, the other one is called Reframe, and then there's one called Rum. There's one called Ohm as well, but I think Ohm has kind of died a slow death. Most people use Reagent or Reframe because they kind of come with state management bundled in. I like Rum. Because Rum is Rum is state agnostic, so it's just the React library. It's just wrapping React, and how you manage your state you can then define. So you can add other ways of handling state. You can write your own. And I quite like that, the composability of that. I prefer little libraries over big frameworks. So let's add Rum. And I'm going to so typically for just as a side note, for Spacemacs with Projectile, once I've gone and ignored all these files that I don't want to commit, when I start searching for files inside of Spacemacs, inside of the project, it will actually ignore those. So I just have to do the work to write the git ignore. But before I do that, I'm going to just add Rum. So again, simply just add the library that you're using, and then its version. And then I'm going to I'm just going to restart the Clojurescript REPL. Actually, I wonder if I can reload. No. Alright, I can't remember the Figwheel command, so I'm just gonna do this. And then while that starts, let's somehow ignore all these files. Yes, Figwheel main and dev. I'm gonna not do the get ignore now. I'll do it later. Right. That should again load us a new window. And now I've got Rum. So Rum, adding Rum is straightforward. In my namespace, I just say require rum.call as Rum. Evaluate that. And now I've got access to Rum. Okay. Right. Dev C. Yeah, sweet. Right. Okay, so a Rum component kind of looks like this. Dev. So you get different ones. You get dev C, which is just making a component, and then you could get dev CS, which is a component that has internal state. I'm just going to call this my app. It would be a Rum reactive. I'll get to this in a bit. It takes a state, some sort of state, and I use that star. So this, I'll get to why I use that, and then it's just going to do an h1. Before I do that, I'll say let. So I want my state. Okay, so before I do that, let me just define some state. So I'm going to do def. I'm going to call it state, and then I'm going to use an atom. So an atom is like a tiny DB inside of Clojure. I'm not going to. It's one of the types, but it's asset, etc. Set. Thank you, Max72. I didn't see it in time. There, people schooling the guard, teaching them about Clojurescript. You guys can check the chat for how you set the inner HTML. It will look like that. Let's quickly hide that and that element, the app. Save that. And there you go. Hello. Thank you for reminding me how stuff works. Right, and again, if I can type in there and it will just live reload. Right, awesome. Chat is awesome. All right, how are we looking on time? Oh, I've gone for an hour already. Time flies when you're having functional programming. Because puns. I'm tired. I have twins that are 6 months old tomorrow. They don't sleep much, which means I don't sleep much. Anyway, right, got some state. I'm going to just, for now, make the state like a little string. Let's do hello world. And then if we look at state, we can see it's an object, and then we can deref it to get to the value of the state. okay, which is hello world. Shorthand for this is just an @ sign. So that's will also give you the value. Now the nice thing about state, about an atom, is I can change it. So I can say reset the atom to Boda, right? Reset. I have to actually give it the atom state. Okay. Now it's Boda, and now if I deref that state, it's no longer hello world. It is Boda. Okay, so I'm going to do that. State, current state. So what we want to do here is we want to use rum react, and that will then look at the state. And yeah, that will look at the state. It will return the current state, and then I'm simply going to do h1 and again print out the state. Then what I want to do, let's get the element. I'm just going to do it all in one. Rum mount. I mean, it's React mount, just hidden. Going to call my, and let me just check that app function does evaluate. Going to call my app function with the state atom above, and then I'm going to do JS get element IDJS document app. Just want to check. Yeah, that's right. Okay, so technically this should work. So didn't work. Objects not valid, React children. Oh, sorry, that should be current state. There you go. All right. And now again, if I change that. Right. Now, this is all fine and well, but there's a problem here. So, because one thing I can do is I can reset the state again. Reset. My state to foo, and if I evaluate this, this should change it in the browser. But now I'm going to save the file. Oh, let me just, I'm going to be stupid. If I save the file, it reverts it back to this original hello world, right? Because it's running all this code again. So what we want to do with our state to be cool, not cool, to be functional, is I want to do dev const. Is that dev once, not dev const. I'm living in JavaScript world. All right. So what this means is that the next time Figwheel runs over this code and compiles it, it will say, hey, I have defined the state, I don't have to define it again. So I can do reset foo. Just going to open the dev tools over here. I can save my file. You'll see that it saves. I can do some more things here that's irrelevant to anything. You can see again there it actually reloads the code, but it's not reverting it to hello world. What's amazing about this is now I can go through my app, so I've got bunches of pages. When I make a change, I don't have to go back to the start. Okay, my state doesn't reset. On the page that I'm at, I can work on it, I can change the code, I can save it, the code gets live reloaded, the CSS will update, yada yada yada, but the app won't move around. It's a bit difficult to see it here because I've just got this one tiny page, but this makes a gigantic difference. The other thing that I can do is, again, So let me go into the this is the actual REPL running. Again, I can do, if I do JS alert here, we'll see it happen over there. But what I can also do is, I'm inside of su.core, is I can reset my state. Or let's do something interesting. So I can set, let's just look at what it is. The state is foo. Alright, so I can say set my state, and this actually takes a function. So I'm going to combine the current state. Let's make it funny. Wait, I'm gonna reset at state. That doesn't have to be at, to Batman. Okay. It's going to reset it to Batman if we check it in the browser. And again, I'm not even at my code file now. I'm just working with the state I'm just working with the state, like the actual state that's there, and it's changing it in the browser. The state doesn't have to be an atom. For one of my apps that I did, I used a library called Citrus, which is a state management library, where the state is it's where the guy has his custom thing. You can do a data. It doesn't have to be. So with Rum, especially, Rum is state agnostic. You can do anything. That state can be an API call that comes back. I mean, you just have to write the code around it. What it does need to do is it needs to have that observable ability. So with a state, with an atom, you can observe the atom and change it when it changes. It has to have that for Rum to be able to pick up that change. I'm not entirely sure what the interface is there. It's probably watchable or something like that. And an atom implements that. So you'll need something like that, because otherwise the state will change, but the browser won't know that it changed, so it won't do the re-render. I'll get to that now. I want to show this. So I can do set star state. This takes a function, right? So if you remember, I can do that as a function. I'm going to call string, which is just basically string concatenation. I'm going to take the input, and I'm going to go add man, or no, whatever. Run that, and that didn't work. Why not? Set state. What am I doing wrong? Oh man, that's right. State. Now state's a function. I returned a function. That doesn't seem right. Let's try again. Swap. I'm an idiot. Sorry. I'm going to refresh the browser because I used the wrong function. You said state. Swap. Swap is what I was looking for. State. Ooh. String. Posit in. No. Right. Okay, and if we show the browser, now I can do that a gazillion of times, and it will just append that state. So one of the things we do is kind of like Redux, is you dispatch changes, right? You dispatch actions or events or whatever you want to call them. So when someone clicks, it's that single one-directional data flow. So when I want to do something, I click a button, I dispatch that change onto a queue, and then there's something that reads off the queue and then updates the state. When the state gets updated, the view gets rendered. All right, it's getting late, so let's finish off. I'm going to make another component I'm going to call it counter. It takes a state here. I'm going to call 1, right? This is going to be a, actually call this count. Just call it count. I can do rum static, which is like a static component. You can also do things like this, will mount, and then I can do, this takes a function that takes a state. I can do print mounted, and then return the state, etc. So you can get to all that React functionality like this. I'm going to do count, then I'm simply going to do h1 with the count. Let's do this string count. And then I'm going to move this just up here. And then I'm going to call this React. I'm going to call this function, let's give it a capital. That's right, and now I'm going to call this from here. Counter, this will take the current state, so, and then I'm going to refresh because I want that. I technically don't have to refresh. I can go into the REPL and manipulate the state, but I'm just going to do that over there. And then I can simply do below it or next to it, I can do a button, right? Click me, let's keep it like that. Right. Oh, so interesting. Lisp always returns the last thing you give it. So I've got the h1, but it reads that as the last thing. So I have to actually wrap this in div. All right, like that. So there we got it. Now, obviously, click me doesn't do anything. I can do styles. So this is Bulma, so I can do button. And again, this is just, so this is, it's called hiccup syntax, which is just an HTML representation of using Clojure data structure. So again, that says I've got a tag. That's what it is. So this can be button, it can be form, it can be any valid HTML element. You can do that as the class. So I can do is primary and it will turn green. And then I can hook into things. So I can say on click, do something. Okay, so I can say JS alert. So if I click it, it alerts. I actually wanted to show you the mounted. So there, every time that app mounts, it's actually printing mount. So just show that that also works. I'll take that out. And then obviously we want to increment that counter. So as a so this is, you typically won't do it. You'll typically have some event queue that you read off of. But just for today and as a final thing, I'm going to swap my state. This is bad design because now I'm looking at the state from outside. So you typically not want to do that. You'd rather dispatch it to a queue and decouple things a bit better, and then you can also test on that. But just for tonight, I'm going to do this, and I'm going to pass in a function called inc. So basically, inc just increments whatever number you give it. So there you go. Hit save, and now when I hit click, it's going to increment that counter into infinity. It's very easy to, I'm not going to click it to infinity. It's very easy to add like history. So you can just watch the atom, save the state in a list, and then you can have little buttons going backwards and forwards. Yeah, all right. I'm going to call call it there. We've been going for like an hour and 20 minutes already, so, and I see most people have dropped off. Thanks for watching. I'll post this onto YouTube at some point, and I'll be streaming again next week, same time. What I want to do next week is I want to look at some interactive, literate development, also using Figwheel, where we'll build out some components. Yeah, thanks for watching. Oh crap, yo, what do you mean what just happened? You've been closure scripted. Oh, thank you for watching. I'm gonna play you some outro music because I like chiptunes. And if it sounds terrible, it's because I don't have a nice audio setup yet, or I'm lazy, whatever you want to call it.